This evening we are going to discuss quantities which we have looked at. We looked at last week. Last week we saw that we could group physical quantities into what are known as base quantities. There are 7 of them. We can also group physical quantities into what are known as derived quantities, and there were a lot more derived quantities than base quantities. There is another way in which we group physical quantities in physics, and that is grouping them as scalars and vectors. So we're going to see what vectors are and what scalars are. And then later on, as this lecture proceeds, we are going to see that when it comes to vectors, direction is very, very important. So if we want to add vectors, there is a way in which that is done, and you're going to see how we can effectively add vectors using something called components. And I think next week we'll see what that is. Okay. So as I've mentioned, all physical quantities in physics, we can group them into scalars and vectors. This grouping or classification of physical quantities as scalars and vectors does not take into account whether the particular physical quantity is a base quantity or it's a derived quantity. That's not looked in. Now, a scalar is defined as a physical quantity that only has magnitude, or a physical quantity that only has size. That's what a scalar is. For example, mass. The mass of an object has got size, like 10 kg or 5 kg. 10 kg or 5 kg, but mass does not have direction. You can't say 5 kg towards the south, or 5 kg towards the west, or 10 kg towards the east. There is nothing like that. The reason why we can't do that is because mass does not have direction. It has got size, yes, but it doesn't have direction. Mass is not the only physical quantity which does not have direction. Examples of other physical quantities which don't have direction are time. Time doesn't have direction. The duration, the time which we are interested in physics, when an event is actually happening, if it happens for 30 seconds, there is no direction in which direction, there is no direction there. It's just how much time, which is 30 seconds, without any direction. So that is what scalars are. Scalars are physical quantities which only have direction. So during the course of the lecture, we're going to see other examples of quantities like that. Then there's vectors. Vectors are those physical quantities which have direction and magnitude. So they have got magnitude and direction. They have got two things. There's magnitude and direction which they have. Again, we're going to see examples of physical quantities which have got magnitude and direction. For example, distance. If you walk a distance, if you walk a certain length, let's say 100 meters, we just say that you have walked a distance of 100 meters. That distance of 100 meters does not have information about the direction in which you're walking. You just walked a distance of 100 meters. So a special length called distance is an example of a scalar, because distance does not carry information about the direction, it just has size. But there is another physical quantity which is related to distance, which is called displacement. Displacement is distance in a specific direction. So you walk 100 meters towards the east. That is no longer distance, but that's what's called displacement. So there is how much distance you've walked, how much length you've walked, the 100 meters, and the direction in which you have walked, which is towards the east. So these kind of physical quantities which have got both size or magnitude and direction, that's what we refer to as vectors. Are we clear? Are we clear on what a vector and what a scalar is? Hello? Okay, since there is no response, I'll take it people are clear, then I'll push forward. I want, when you respond, don't type, but speak through the microphone so that we see, because I don't have time to look at your messages as I'm sharing these screens, looking at another file, and yeah, so I won't really have time to that. The other thing we're going to do, it turns out that we are also interested in adding vectors. Yes, we are also interested in adding vectors. When it comes to adding scalars, this is something which you know how to do. If you can add masses, 5 kg plus 3 kg, that's 8 kg. Or 10 kg minus 4 kg, that is 6 kg. So you know how to add or subtract physical quantities which do not have direction but only have size, so scalars. So you know how to add or subtract scalars from whatever it is you have been doing. You can have 10 seconds, you add another 15 seconds, you end up with 25 seconds. So you know how to do this addition of scalars or subtraction of scalars. So our focus during the course of the lecture, and until we are done with this thing, is not really on the addition of scalars, but on the addition of vectors. Because there is a direction component in the vector, it's not a straightforward thing to add scalars, to add vectors. So there's something you have to do. And one of those things you have to do, if you're going to add vectors, is a process called decomposition. Breaking down a vector into its components. Okay? These components are how much a vector is in a particular direction. We are usually interested in the x and y direction. So basically what we use for direction is the xy plane. So you draw an xy plane, then you assign your xy plane directions. The x-axis is your x direction, the y-axis is your y direction. The positive x-axis, the negative y-axis, then your positive y-axis, negative y-axis. So you assign these things direction. So when you have a vector which doesn't point in a particular x or y direction, you want to find out how much this vector is along the x-axis or how much this vector is along the y-axis. That process is what's known as decomposition. The reason we do decomposition of a vector is because once you decompose your vector, when you decompose your vector, what you're actually going to get is what you call components of the vector in those particular directions. These components, once you decompose the vector, these components can be added like scalars. You can add them the way you add time, or the way you add length, or the way you add mass. That's the reason why we do this process. When you break your vector into its components, the components can be just straight away added like the way you add time, mass, because they point in the same direction. Okay, so our interest also is the addition of, or the addition or subtraction of vectors. That's the thing we are interested in. The reason why we do this is because most of your physics course has to deal with vectors. You meet vectors, so you need to know how to add these vectors and how to subtract them. Okay, otherwise the course is just going to become impossible and you will not get anywhere. You will not be able to solve any problems. Okay, so some of the objectives which we hope you'll be able to attain by the time we are done is how to define a scalar quantity. We have said a scalar quantity is a physical quantity which only has magnitude. Okay, and you should be able to give examples of scalar quantities. I've given 2 examples so far. I've given time and mass, then, and also distance. Time, mass, and distance, those are examples of scalars because these physical quantities have got size but they don't have direction. The next thing is, which we want you to be able to know, is how to define a vector. We have said that a vector is a physical quantity that has both magnitude, or the size, and direction. And I have given one example of this, something called displacement, which is distance in a specific direction. Okay. The other thing, there are other examples of these vectors and scalars, which is what you're going to see. The other thing you need to be able to do by the time we're done with this topic of scalars and vectors is you need to be able to break down a vector into what are called components. Okay, once you are able to break a vector into what are called components, these components thereafter can be added just like the way you add scalars. Okay, and for add or subtract coplanar vectors. Coplanar vectors are vectors which act in the same plane. Okay, so now we start with scalars and vectors. So like I said, the physical quantities, whether they are SI based quantities or derived quantities, you can divide them into two groups: scalars and vectors. Scalars are those ones which have got size or magnitude only. Vectors, on the other hand, are those ones which have got size and direction. Mathematically, you can show a vector like this. So if you have vector A like that, then you can show that this particular vector, mathematically you can write it as A with an arrow on top, or you can type as a boldface later. Also, most of what you're going to do in physics as you're solving your problems, you are going to represent vectors, and these vectors you're going to represent them like this: a line with an arrow. The line denotes, or the line shows the size of the vector, and the arrow shows the direction in which the vector is acting. So in this case, we have a vector which starts from point A and ends at point B. Normally what you'll be doing is, on top of this line, you can put the symbol which denotes that particular vector and also the size. So on top of this line, we'll be putting the symbol and the size of that particular physical quantity. Then the arrow is what's going to show the direction in which the vector is acting. So with this information, you can adequately express a vector by showing its size and also the direction in which the vector is acting. Do we have any questions? Do you have questions? David.
So, if we continue, I come back.
Phineas Mutonga, your microphone needs to go off. Do we have questions about how we represent a vector? You draw a line. That line does not need to be drawn according to scale. You just draw a line. Then on top of that line, you put the symbol of the quantity of the vector and also the size. Then the arrow on the vector is going to show the direction in which the vector is acting. That's all you need to do. Are we clear with that bit? Sorry?
So we are clear, but you can't see anything. We can't see anything.
You can't see anything.
No, sir, we can't.
No, we can't see anything, sir.
Oh, okay. Let me see. Present now. So maybe the internet must have cut.
No, we can't.
We can't see anything, sir.
We can't see anything.
Just wait. Pundo, what's the problem? Can you see? Are you able to see the presentation?
Yes.
Can I move forward?
At least now.
Sir.
Yes. Do you have a question? Pundu Leonard, can you switch off your mic? Can you switch off your microphone? Derek,
Yes.
switch off your microphone if you're not speaking. Derek, microphone. Okay, next. This is how we add scalars. Basically, like I was saying, addition of scalars is a straightforward business. For example, if you've got 5 kg plus 3 kg, that gives you 8 kgs. So when you are dealing with scalars, physical quantities which do not have direction, they only have size, the addition is just straightforward. As you can see, how do I get 8 kgs? So it's the size of the quantity, which is 5 plus 3, that gives me 8. Then the unit stays the same. We are adding masses, so you can only add the same physical quantity with different sizes. Okay, so as you can see, I'm adding mass 5 kg plus another mass. I'm not adding mass plus time. No, you can do addition or subtraction of the same physical quantity. Okay, if those quantities are scalars, they do not have direction, so 5 kg plus 3 kg, that gives you 8. 25 seconds, this is time, minus 13 seconds, you remain with 12 seconds. Here, 25 meters plus 50 meters, you get 75 meters. There is no information about the direction in this case. Then here, with the number of moles, 1.5 moles plus 0.7 moles, there is no direction. We're talking about how many atoms are in a particular substance. You get 2.2 moles. So when it comes to adding scalars and subtracting scalars, this is a straightforward business, and we will not spend our time on this. The new thing which most likely you do not know how to do is how to add vectors, and that's where we are going to focus the rest of our attention for this lecture and the ones for next week. Okay, so the first thing you're supposed to be aware of is that when you are dealing with vectors, when you want to add vectors and when you want to subtract vectors, you cannot afford to ignore the direction, because the direction is very, very important. As much as the size is important, the direction is also very, very, very important. So you can't ignore the direction. Okay. The other thing, is there someone speaking? Mwaka, what I say? Mwaka Imanga, what are you saying? The other thing which you're supposed to be aware of, which you need to know, is what we call the result of adding vectors, adding or subtracting vectors. When you add vectors or when you subtract vectors, what you get is what we call the resultant. This is very, very important, because the resultant is connected to important stuff. So when you're adding vectors or you're subtracting vectors, what you want to get is something called the resultant, or the net sum, whatever it is, but resultant, that's what we call that. Okay, the topic here says vector addition. Okay, we could have said vector addition and subtraction, but when we are dealing with vector addition, subtraction is considered to be a form of addition. Okay, how is that the case? Because when you have got a vector which is pointing in the opposite direction to other vectors, that vector pointing in the opposite direction, we consider that to be a negative vector, and therefore it's going to have a negative sign. So when you're adding these vectors which are positive plus this vector which is negative, it's going to look like you are doing a subtraction, when in fact what you're doing is just simply an addition. You're adding vectors which are pointing in different directions. In this case, when you're doing subtraction, opposites. Okay, so that's the first thing. The first thing to note. The second thing, the third thing actually. First thing to note is that direction is important. The second thing is the sum of adding vectors is called the resultant. The third thing is that we do not concern ourselves with talking about vector subtraction, because subtraction turns out to be a form of addition. Okay. So, what the heck happened now? Okay, my connection got cut. The next thing, we want to talk about is the direction. We want to focus a bit on the direction. When you're adding vectors, the vectors you might be adding might point in the same direction, or they might be parallel. Okay? If your vectors are pointing in the same direction, or your vectors are parallel to each other, the direction of your vectors is parallel, or your vectors are pointing in the opposite direction. One vector is pointing this way, the other vector is pointing in the opposite direction. So your vectors are pointing in the same direction, or your vectors are parallel to each other, or your vectors are pointing in opposite directions. Okay? We say that the vectors are acting in the same line. This is a language we use. When two vectors are pointing in the same direction, or when two vectors are parallel to each other, or when two vectors are opposite each other, we say that the vectors are acting in the same line. Okay? So how do we add vectors which are acting in the same line? Vectors which are pointing in the same direction, vectors which are parallel to each other, or vectors which are opposite each other. How do we add these? The following is the rule, and this is why we come up with components. Okay? The resultant of adding two vectors acting along the same line is the sum of the magnitudes of the two vectors. If you've got two vectors, you want to add them, then they're acting in the same line, meaning that these vectors are pointing in the same direction, or these vectors are parallel to each other. When you add them, then you get the resultant. The resultant is going to be the sum of the sizes of those vectors. So you get the size of this vector, you get the size of this vector, you add the sizes the same way we're adding the masses here. So if it was a vector, you would say, if this was a displacement, you would say 25 meters plus 25 meters, then the resultant is going to have a displacement of 75 meters. You only do this if the vectors are acting in the same line. So you get the size of the resultant. It's just the sum of the magnitudes of the two vectors. The sum of the magnitudes of the two vectors. How about the direction? The direction of the resultant remains unchanged. So this is very, very important. If you add vectors which are pointing in the same direction, or these vectors are parallel, the resultant is going to have a size which is equal to the sum of the magnitudes of the two vectors, and the direction of the resultant will remain unchanged. The resultant is going to have the same direction as the two vectors, because these two vectors are either pointing in the same direction or they are parallel. Is this clear? Okay. Next, if one of the two vectors acting along the same line is acting in the opposite direction, so if one of the vectors which is acting in the same line is acting in the opposite direction, now the two vectors are parallel, but one of them is pointing in the opposite direction, then its magnitude is given a negative sign. So vectors which point in the opposite direction are given a negative sign. So during your physics studies, you are going to see some physical quantities which have a negative sign. Those physical quantities which have got a negative sign are actually vectors telling you that that physical quantity is pointing in a direction which is opposite to some direction which has been chosen. Okay, the direction which is positive is something you will have to choose. So as we are studying vectors, you will have to choose which direction is going to be the positive x-axis, which direction is going to be the negative x-axis, which one is going to be your negative y-axis or positive y-axis. So if you have chosen that, then something is pointing in the opposite direction, we give it a negative sign. And here you have a table which shows more examples of vectors, for example, and scalars. For scalars, you've got mass, length, time, electric current, temperature, amount of substance, light intensity, area, volume, density, speed, energy, work, power, frequency, charge, voltage, resistance. All these physical quantities have got size. What they do not have is direction. So they are scalars. We group them as scalars. These other ones, displacement, velocity, acceleration, force, pressure, momentum, torque, electric field, magnetic fields, these are also physical quantities, but they have magnitude and direction. For example, as I mentioned earlier, displacement is distance in a specific direction. Velocity is speed in a specific direction. Okay, so you've got speed, then there's direction. Displacement, there's distance and direction. The same thing applies with the rest of them. Acceleration, force. When you apply force, you pull something or you push something in a particular direction. Are we clear with the examples and how we add vectors in the same direction?
Yes, sir.
Okay, that's
Yes,
good.
we are.
That's good.
Yeah.
Here we have got some examples of what we mean by adding vectors in the same direction. So here, for example, you have a box. There is a force of 10 newtons acting in this direction. There's another force of 10 newtons acting in that direction. These two forces, as you can see, they are opposite each other, but they're in the same line because they're kind of parallel, but they're opposite in direction. So in this case, when you've got things like these, two forces acting in opposite directions, you need to choose which direction is going to be positive and which one is going to be negative, so that we know which force is pointing in the right direction and which one is pointing in the opposite direction. Any vector pointing in the opposite direction is going to be given a negative sign. So here, if we choose this side where the mouse is to be positive, so this 10 newtons is going to be a plus 10 newtons, then this other 10 newtons is going to be a minus 10 newtons. Just because we have chosen that this side should be positive. If I choose this end to be positive, then this force is going to be a positive force, plus 10. That other one is going to be a negative force, minus 10, because it's pointing in the opposite direction. The resultant of these two forces is the addition. So I'm adding plus 10 newtons plus minus 10 newtons. That gives me 10 newtons minus 10 newtons, and I get a 0, and that's why there is no force here. The resultant is a 0. So when you have forces pointing the same, acting in the same line, it's very easy. The only thing you need to do is you need to choose the direction. Which side is going to be positive, which side is going to be negative. That is up to you to choose. If you like this end as positive, that's fine. So you choose this to be positive. Then if you choose this to be positive, this other side has to become negative. So what it becomes is up to you. You have the freedom to choose which end is going to be positive and which end is going to be negative. Here we have got two forces, 10 newtons, 10 newtons, and as you can see, they are parallel to each other. But if they are parallel to each other, we say that they are acting in the same line. So 10 newtons plus 10 newtons acting in the same direction, we just add them. We end up with a resultant which is 20 newtons. Then here we have got a 10 newtons this side, you've got an 8 newton this side. So if you choose this side to be your positive direction, so you're going to end up with a plus 10 newtons. Then this side is going to be negative, so you're going to end up with this side with a negative 8 newtons. So 10 newtons plus minus 8 newtons, that is going to give you a resultant of 2 newtons. Once you choose your direction, say this direction is going to be positive, and you stick to it, any vector which is pointing in the opposite direction to your positive direction becomes a negative vector. Are we clear?
Yes. Yes, sir.
Okay. So that's how we add vectors which act in the same line. Okay. However, things are not going to be so easy so that you're just adding vectors which are acting in the same line. Most definitely, your exam question is not going to come like that. What's going to happen is you're going to have two vectors or three vectors acting along different lines. Your vectors are going to act in different directions. So that's basically what you're going to have. Now, when your vectors are pointing in different directions, there are different ways or methods of doing that. How do you add vectors pointing in different directions? So that when you add them, you get your resultant vector. One of the methods which you can use, but which we are not going to use, is this one was supposed to be something called a triangle of vectors. I will need to show what it looks like, these vectors. So these triangles. So you've got two vectors here, vector A starts from here, it goes all the way up to there. That's vector A. So it has got a certain size and direction. Then there's vector B. Vector B starts from here all the way up to there. So it has got also a certain size and direction. So if I want to add vector A and vector B, so I'll start from here, this end, I'll go like that along vector A, then I reach the end of vector A, then I start going up like that along vector B. So I end up there. Okay, that where I have ended is the same as me starting along this, from this bottom, the red point, I go along the red line there up to there. These two are equivalent. So me going this side, A, vector A, then I go vector B, is the same as doing A plus B. This red line is what is known as the resultant vector. That is what A plus B looks like when you're talking about vectors. So if A is your vector, then B is another vector. If you add them, you add one on top of the other. Okay? Like that, what you have done with A plus B, you end up with these. A plus B. So this is vector A, then you add vector B like that, then you end up with these. This with two arrows, this is your resultant vector. Are we clear? On what A plus B, how you get A plus B? With a triangle of vectors?
Sir.
Yes.
Sir, I have a question.
Go ahead.
When it comes to add, when it comes
Hello?
the XY, once you're adding vectors, does it mean that is there any possibility of that?
Is there what?
Presenting the vector on x-y plane for you to find the magnitude.
Yes, you can. And that's a method we prefer to use than using these triangles. But we actually do it in an even better way. Okay, So when you're actually solving a problem which involves vectors, you do not use these triangles. Okay? We don't use these triangles. We use a different method at first year.
Yes.
Yeah.
Another question is that some of the questions which comes on finding the magnitudes for the vector, they are being presented on the graph paper.
No. We don't do graph paper here. We are not going to do triangles of vectors, and the things are not going to be presented on graph papers. We're just going to tell you this vector has got this size, this vector makes this angle with the x-axis. That's what we're going to tell you. The other vector has got this size, it makes an angle of this size with the x-axis. That's all. Then we tell you to add them. So there'll be nothing like graph paper, there'll be nothing like drawing triangles like this. There'll be nothing like that. So what you're going to use is a method called using components. Vector addition using something called components. So you have to find out what these components are, and that's definitely something which I'm going to show you next week. Okay. So we move on to vector, this other one. So I get vector A. So here I start from this end, this other side. For the second triangle, I start from this side, I move in this direction. Now the direction I'm moving in, as you can see, is the direction opposite vector A. So when I start from here, I move in this direction, what I have is minus A. Then at the end of minus A here, I move in the direction of vector B. Like that. I move in the direction of vector B, I end up there. So I move minus A, I'm moving in the direction opposite minus A, then I move in a direction plus B. So what I end up with is minus A plus B, which is the same as B minus A. It's the same as me moving from here up to that point. So I'm moving in that direction. So this is the resultant, B minus A. That's what it looks like. Are we clear on what B minus A looks like? How you get B minus A using a triangle?
Yes, sir. Yes, sir.
Okay, next.
Yes, sir.
There is a third triangle here. With the third triangle, I start from the top there. I move in a direction opposite B. So I move down like this. So I'm moving in a direction opposite B. That is minus B. Then after I finish moving in a direction opposite minus B, I move along A. So what I have is minus B plus A. Minus B plus A is the same as A minus B. So in effect, I'm moving from there all the way down up to here. This. So you can see, you can draw a conclusion about B minus A and A minus B. What you see is that it looks like B minus A and A minus B, they have the same size. That's what you can see from the picture. B minus A and A minus B have the same size. But if you look at the arrows, for A minus B, for B minus A, the arrows are pointing up. For A minus B, the arrows are pointing down. So the direction, as much as B minus A and A minus B have the same size, the direction of the resultant vector is not the same direction. They are pointing in different directions. So the resultant B minus A and A minus B are not the same vector because the direction is not the same. As much as the size is the same, the direction is not. Are we clear? If you look at B minus A and A minus B, they are the same size, but the direction is not, because B minus A is pointing up and A minus B is pointing down. Okay, so like I have said, we are not going to be using this method. This method of triangle of vectors is there to just show roughly where the resultant vector is going to point. Okay, you can do a rough sketch of where something is going to point. But we have to do more than that in a physics class. We need precise values of size, and we also need a precise direction. Okay, we need precise values of size, and we also need precise directions. So for us to accomplish this, yes, you can use a graph paper where you draw things according to scale. But if you use a graph paper, then you start drawing these triangles according to scale, it will take you more time than you have. And the process is tedious, and some of you are just not good at drawing shapes and stuff like that. So we want to make sure that everybody succeeds. So we'll be using a different method which does not require which does not require you to have very good artistic skills and stuff like that. As long as you can use a calculator, then you should be fine. And that is what's known as using components, method of components. So next week when we meet, we'll look at item number 5. What is a component of a vector? How do you find the component of a vector? Then how do we use these components to actually, how can we actually use these components to actually add vectors or subtract vectors? Are we clear? Do we have questions on what a vector is, on what a scalar is? Any questions? We have come to the end. So next week we'll be able to do we have any questions? Do we have questions? Okay, so if we don't have questions, wishing you a good weekend.
Some of us.
Ati?
No. Hello, sir. Yes, sir. I'm available.
What? Okay. So, if there are no questions, we'll meet next week. Of course, there is a video recording of this, so we are going to upload the recording to YouTube. You should be able to see it shortly. Okay. So, have a good night and see you next week.
Yes, sir.
Cheers. I'll stop sharing.
Thank you.
Good. You're welcome.